everyone.
Welcome to the Control Engineering webcast, Return on Investment from Collaborative Robots, Market Drivers, Economics, and Case Studies, sponsored by Universal Robots. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering and CFE Media. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with the slides or with the audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with audio or the slide presentation, click on the question mark at the top right corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions box. Type questions for our speaker in the Ask a Question box at the left side of your screen anytime during the presentation. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded, and you will receive an email within a week with the link to the on-demand webcast. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of the webcast. I'm happy to introduce today's distinguished speaker, Early Ewing. As UR Plus Product Manager for Universal Robots, Early Ewing manages the onboarding and development of ecosystem partners, including manufacturers of plug-and-play EOAT, vision systems, software, and accessories. Prior to assuming this role, Early managed sales for Universal Robots in the South Central U.S. Early also held various positions in the product management and sales in the oil and gas industry with Schlumberger, as well as a consulting role with Cohen Resnick. Thank you for joining us today. Early, the floor is yours.
All right, thanks very much for having me, and welcome everyone to the webinar. Today we're going to talk a little bit more economic than technical when it comes to the subject of cobots. Okay, and I think it's important to start off with kind of where we're coming from there. So in the 70s and 80s and 90s, the motivation for implementation of industrial automation was pretty cut and dry to remove labor. Now, of course, there were some secondary benefits of improved process control, quality control, etc., but the primary driver has really been the elimination of headcount. That's what drove the CapEx. Now, fast forward a couple of years, and in the past 5 years, cobot investments are going from a 2-year return, which used to be the norm in industrial automation, down to a 1-year return. And we'll spend the next few minutes talking about how that occurred and what some of the drivers of that are. So industrial robots typically are difficult to set up, have high programming expertise required, typically need safety fences, and really a big ancillary investment on top of the hardware costs. Now, compared to collaborative robots, which are fast to set up, have limited space requirements, can potentially work next to humans, they can be much more cost-effective, driving that ROI down from the 2 to 3 year time frame into, in most cases, less than a year. Now, just what exactly that looks like is demonstrated very well on this slide, where on the left you have a typical industrial robot cell with the fencing, the PLCs, the safety guarding, all of that in place, compared to what is on the right, where you show a Universal Robots collaborative robot on a mobile stand that can be easily moved between applications and set up in minutes. This can really drive our ROI. Now, when we talk about Industry 4.0 in the industrial automation space, you know, that's a pretty common buzzword, right? Typically, though, this is about data, and it's about humans or machines. Now, when we talk about Industry 5.0 and the cobot world, the real driver here is that humans and machines are working together to drive productivity. Now, this is important to understand because there's a common misconception in the marketplace and in the public eye that robots eliminate jobs. Now, here on this slide, we have some very clear data that shows that's not the case. Collaborative robots actually enhance productivity and help businesses grow and scale to fulfill the opportunities that they have available. There's an extremely clear correlation between the introduction of cobots and the unemployment rate, as shown in this chart. Between the end of the Great Recession and the current, you can almost see it's inversely proportional, the unemployment rate and the growth of robots. This very clearly proves that collaborative robots don't destroy jobs. They help grow businesses, which drives jobs. Now, this is important to understand because of the current landscape in the industry. U.S. unemployment is hitting a 49-year low at this point in time. Every time we go make sales calls in the field, what we find is manufacturers that cannot hire enough people. 89% of small to medium-sized manufacturers have difficulty finding quality workers. And this is not a myth. It's happening every day. And the biggest segment that businesses are having trouble with this is in manufacturing. The cobot is a perfect opportunity to help alleviate that challenge. Now, this is not just an economic problem, it's a demographic problem. 10,000 baby boomers reach retirement age every day. And boomers of 55 years or older represent 27% of the manufacturing workforce across the U.S. That means in the next 10 years, as people retire, we are going to have to replace 27% of that workforce. Now, millennials, as most of us know, are not interested in fulfilling these jobs the way previous generations were. 83% of the population finds manufacturing jobs important to the economy, but less than a third would encourage their children to enter those manufacturing jobs, and people aren't applying like they should. We need something to fill the gap. Now, when we continue to talk about those business challenges, consistently, once again, number one is attracting and retaining a quality workforce is the primary challenge of business owners. Okay, you can see that number at almost 68.2%. All right, raw material costs, trade uncertainties, all these other economic headwinds that we read about pale in comparison to the workforce challenge. Once again, we have about 5 million unfilled manufacturing jobs right now. We expect about 2.5 million of those to be filled by increase of the workforce, but we still have a gap of 2.4 million jobs at that point. Something has to come in to fill that, or we're going to see stagnated economic growth in manufacturing. This kind of technology, as opposed to the past when it was about replacing headcount, is about fulfilling the capacity requirements of businesses to grow and keep this economy moving. Now, when we look at the cobot growth projections, and you can look at a various number of studies, but they all seem to focus around the same number of projecting almost a 50% year-over-year growth in the cobot implementation. Now, this tracks very well with what we see in the workforce challenges out in the marketplace, and it's been demonstrated in the past. Now, talking about those benefits of the cobots, one important factor of that is considering the impact on the small and medium-sized business. Now, of course, we do business with large organizations all day long, but by driving down the cost and improving the ROI through the implementation of cobots, what the industry has been able to do is provide access to this technology to businesses that previously were not able to take advantage of industrial automation. Businesses that are in rural areas, that have trouble hiring, that aren't as attractive as major technology companies to millennials. This is really where the cobot has come in and saved the day in a lot of cases for a lot of our customers. I believe we have a little video here describing the testimonials of several of our customers on how this technology has impacted their business.
When we first started looking into automation, I was surprised to find that we could afford a 6-axis robot and a collaborative one at that. I assumed those systems cost hundreds of thousands of dollars. The return on investment on our initial system was less than 2 months.
The return on investment is less than a year, probably about 7 months.
The ROI on the robot was probably about a 4-month return.
For the ROI on purchasing the robot is slightly less than a year, actually. So I'm very happy about that.
With the price you can buy the universal robot for, it's stuff that you're willing to invest knowing how quickly you can get the ROI back on it. To give an idea of ROI investment, you're looking at a savings of about 34 days it takes to get the robot paid for, to justify the means of buying that robot.
We estimate the ROI was about 6 months at its current configuration.
So in case of robots, we found that in just 14 months, the robot will pay for itself.
The ROI on the robot, I would say the robot itself, payback was less than 4 months.
These robots are probably 5 times as cheap, or 1/5 the cost of a traditional industrial robot.
We think that this system will pay back for itself in under 6 months, and that's just based by the cost savings and increased output that it provides.
Thank you very much for the slides, for the video. Okay, so let's talk about how we achieve those ROIs. The first thing is in the cobot hardware. Okay, at least in the case of universal robots, cobots run off 120 volt single phase power. You can plug them into the wall just like you would any other piece of equipment or a laptop. The mounting hardware is extremely easy. This contributes to the low footprint of the robot, allowing you to implement it into cells and systems designed for humans without reconfiguring your entire line. Okay, and also another important factor about cobots is safety. The robot is featured with several different methods of implementing engineering controls to satisfy a risk assessment. Provided your risk assessment qualifies for not using caging, this also helps with the cost, the speed, and the impact of implementation. Okay? From an engineering perspective, UR Plus, which is the program that I'm involved with, works with third-party companies to develop peripherals that are plug and play. So the difficult integration of the end-of-arm tooling that creates an additional barrier for our customers is no longer present, so that the customers get a consistent user experience with the ease of programming of the robot as well as they do with the end-of-arm tooling to help them accomplish their task more easily. There is also free online training available to help bring users and operators up to speed on this technology to further aid in implementation. This can typically be an enormous investment when it comes to traditional automation. Now, on the financial side, one thing that's extremely important is lead times. Universal Robots can deliver a robot from order in about 2 weeks. What this allows you to do is move the start date of generating that return on investment that much farther up the chain. This helps out with your project and implementation schedule. No longer is the robot the component that the customer is typically waiting on in the project. Now, implementation models. Right here we have a pretty simple graph that shows on the vertical axis the cost of implementation, and on the horizontal axis the complexity of implementation. Now, traditional industrial automation sits squarely in the top right corner with the integrator. Okay? Now, we use integrators very extensively for hard problems. The easy problems, however, the technology has enabled many different models to go after those problems. Okay? The simplest is to do it yourself. That's when the customer receives plug-and-play peripherals, the robot in a box, and is able to get up and running and handle their application immediately. Then we also have a layer of value-added distributors and a new kind of layer that's emerging in the integration space called the lean integrator. Value-added distributors are distributors that typically have their business model revolving around the sale of components, but also have applications engineers and programming expertise for slightly more complex problems. Now, the lean integrator, on the other hand, does a turnkey solution. They are able to sell a result and deliver a product to a customer involving the robot with a higher level of expertise, but focus on those intermediate applications to lower those costs for those customers and provide the right amount of expertise and engineering for the problem. All of this is enabled by this technology. Now, this is one thing that's extremely important when looking at your ROI. Traditionally, when you're looking at industrial automation in the past, in order for a robot system to work, you had to have the entire cell end-to-end automated, otherwise it wasn't predictable enough for the robot. With collaborative robots, by utilizing the efficiency of humans and robots working together, you can very easily stage in automation as you generate your ROI, incrementally automating your processes in the most efficient way possible. As it says, the most demanding 20% of an automation project consumes 65% or 60% of the project cost. Now, that's the 80-20 rule too. You're probably getting 80% of your benefit out of automating part of the process, and that's where cobots really shine. Now, machine utilization is also another important factor. Due to the labor shortage in a lot of cases, idle machines is a big problem for business owners. Right? You hear spindle time in machining, all these different metrics. Utilizing collaborative robots acts as a force multiplier for your workforce, enabling you to optimize that machine utilization time as well as the robot utilization time due to its portability and flexibility to move from machine to machine and job to job. A lot of companies are actually using this as well to just extend the second shift time. We're going to set up a run of parts, and we're going to let it run after everybody goes home. That gets me 4 extra hours out of the day that I would not otherwise get, driving up my utilization and improving my ROI. Now, some indirect contributors. We talked about this earlier when we were talking about traditional industrial automation and how a lot of times this isn't taken into account. But with cobots, this becomes more and more important. We have countless customers who have been able to take larger orders as a result of the increased capacity, gain new customers and contracts, improve the quality of the parts that they're outputting, reduce their real estate costs and floor space utilization, and more importantly, reduce their turnover and improve their hiring practices. Because the generation that is entering the workforce right now is much more apt to work with robots than in the past. Now we'll talk about a couple of case studies that demonstrate this. The first one is all-access machining. Okay, this is actually in Dallas, Texas, and was a former customer of mine. They had a big problem with lack of available employees. They were turning away orders, had tons of downtime on their machines, and they had legacy machines and no robot programming skills in-house. Now, this is a very interesting one in that they went from 0 to 4 robots in about 3 weeks. Since then, they've automated 6 different applications, completed their first automation implementation in 2.5 months, and got an ROI of 4 months. Spindle time on their machines increased from 8 to 20 hours a day, and their accuracy and quality of their parts improved drastically. Now, one of the other interesting things about this is they have actually hired more automation engineers than operators since the implementation of this technology as they continue to scale their business because of the efficiencies gained. The next is Zipper Tubing out of Arizona. Now, they make cable wraparound tubings used in the automotive and aerospace industries. They were faced with a very large contract that they struggled to keep up with, and turned to Collaborative Robots to try to solve that contract problem and fulfill that demand from the customer. They had a very high mix of products which posed significant difficulties with the implementation of traditional industrial robots. They not only self-integrated their robots, but were able to set up these machines in an incredibly quick time. They achieved 0 part defects with the ability to specify 300% more tolerance than with a manual operation. Now, in this case, they were able to reduce their labor force by 32% and reassign more customized, highly skilled tasks to their remaining employees, thus doubling their production and enabling lights-out manufacturing. Now, Paradigm Electronics, located in Toronto, is a manufacturer of speakers and enclosures. Now, they were struggling to find skilled labor as well for surface finishing, which creates repetitive stress injuries, is a job no one really wanted to do. Okay, so they implemented a pendulum-type operation where the robot is actually mounted upside down, out of the way, and does the initial buffing and sanding. Then the operator takes over the final sanding and polishing, where the quality inspection and the surface finishing really needs a human touch. So this is a great example of how the robot was able to do what robots are good at and augment the human to do what humans are good at. They increased their throughput by 50% and had an ROI of only 14 months. Task Force Tips is another interesting one. It's a manufacturer of firefighting equipment in Indiana. They wanted to transition their operators from tending machines into more complex and valuable tasks. They've long integrated robots with machine tools, but wanted a flexible solution that was more accessible to a greater number of their employees. They installed 4 cobots, 3 machine-mounted, and 1 on a portable cart that was able to be moved around the facility as demand dictated, and got a 34-day ROI. That's just a little bit over a month. 1 hour per operator each shift to set up the robot for the task it's going to do yields 21 hours of unassisted machine tending time. They reduced their staffing requirements from 7 to 3 operators, which allowed them to redeploy the other operators to increase their other capacity and eliminate downtime. Now, Toolcraft Incorporated is a small contract machine shop located in Seattle. They had large order and capacity constraints that were difficult to achieve without adding a 3rd shift. If anyone has ever worked in a manufacturing environment where you've had to manage or staff a 3rd shift, you know how difficult this can be. Who wants to work overnight tending machines? Okay, they had complex processes that included a multi-thread part that need to be loaded into a 3-step CNC operation. The initial robot process expanded to include dipping and rinsing parts after machining to fully free up the operators. Therefore, the third shift was fully enabled by limiting their staff requirements to hit that third shift production requirement, and their production increased from 255 parts to 370 parts per week, yielding a 12-month ROI. This gave them the ability to finish that year's production 7 weeks sooner on the job that they thought they could originally not achieve in the first place. This has been great for getting additional orders and helping build the business at Toolcraft. Now, we talk a lot about machine tending, but cobots really should be thought of as a tool. You can see here on the slide many different applications that we list out, but the reality is that the robot simply goes from point A to point B. The easier you make it to program and the more flexible you make it means that it is a flexible tool around your shop to fulfill any duty that your imagination dictates. This is where the training sparks ideas. This is where the initial implementation of robots leads to future improvements. Flexibility, ease of deployment, and ease of use is the absolute key to collaborative robots.
Well, thanks so much, Early. There was a lot of good information there, and I love the case study examples. When you talk about implementation of robotics, I think there's a big hurdle involved about people jumping in for the first time, and you demonstrated a lot of great case studies that maybe we could explore some more about. First, on to the question and answer session, and here's a little bit more information about how that's going to work. So our webcast presenter, Early Ewing with Universal Robots, is available to answer questions from the audience. Type your questions for the presenter in the Ask a Question box on your screen, and thank you to those who have already done so. We'll get to as many questions as time allows, and the questions that we do not get to today will be posted online at controleng.com with the archived version of this webcast. Remember, you can download a certificate of completion or a copy of the presentation by using the Event Resources tab on the left side of your screen. So now we'll get on to our questions and answers. So, yeah, that's your part, Early.
Yeah,
okay,
yeah, I got
so
it.
Have collaborative robots been used for oil and gas applications? And do you have any return on investment benefits in those areas?
Well, I actually love this question with my background at Schlumberger. So yes, absolutely. Typically we think of oil and gas as being very heavy-duty applications, but especially when you look into the service and manufacturing side, valve manufacturers, downhole tool manufacturers, inspection becomes a really interesting thing. Arc welding becomes a really interesting thing. The thing about oil and gas, when you look at return on investment, is the intangibles become extremely important, especially when you're talking about quality inspection, because the downside risk of a part failure in the field is so high. You know, I can tell you when I was working in Alaska, it was about $500 an hour rig downtime. And if we showed up with a part that wasn't properly inspected or properly manufactured, that could lead to non-productive time, which has, an incredible potential cost of hundreds of thousands or millions of dollars. So the ROI is very easy to justify from a risk mitigation standpoint in that case. The other aspect of this is, the cost of labor and skilled labor and even unskilled labor in the oil and gas market is comparatively high to traditional manufacturing industries. So, typical operations are inspection, arc welding, machine tending, all of that, but the benefits in the oil and gas industry are extremely tangible.
Thank you. Another question, how to select and validate the robot type for a particular application? You had a great slide toward the end there that showed just a myriad of opportunities for collaborative robot. How do you decide what kind of robot to use for a particular application?
Well, there's a typical misconception out there that if I'm going to use a cobot, it has to be for a collaborative application working next to a human. Otherwise, I'm looking at the industrial space. The problem with that argument or that metric is that the benefits of ease of use, flexible deployment, and flexibility in applications are often ignored in that. And those benefits for a cobot, even in an industrial application, still contribute to the ROI on that application. So my typical advice there is if it's within the performance envelope of the collaborative robot, the cobot is typically the better choice because of that ease of use and that ease of programming, even if it's not going to be a collaborative application. Now, of course, for collaborative applications, your cobot is typically your only choice if you want to fulfill that. And within our model range, it typically depends on your payload and reach requirements.
And by a collaborative application, you mean working in proximity of a human?
Yes, satisfying the requirements of TS 15066, the Collaborative Robot Safety Guidelines.
So I love the metrics of the ROI that you gave with your examples. The next question addresses that. It says, what type of return, and is it always in monetary terms, or can it be something else factored into the ROI?
Absolutely, and of course you can assign a dollar value to anything, but you know, we spoke earlier in the oil and gas question about the risk mitigation factors of implementation of automation versus a manual process. There's also the elimination of other hazards. Even in a non-collaborative application, a cobot can be used to take over a process that potentially creates repetitive stress injuries in employees, contributes to turnover. All that, of course, can have a dollar value. One of the biggest things, though, with human-robot collaboration is human beings are typically inherently more productive in that because the robot is taking over the dull, dirty, and dangerous jobs that humans don't want to do and allowing the humans to work on more interesting things, which helps you attract the type of employees that are going to contribute to your yield.
I think you gave one of the examples where they redeployed operators in other areas where they were having trouble filling. So they're able to redeploy existing staff and talent to do something that may be more interesting or useful for the ongoing business.
Absolutely. It allows you to scale up in the presence of the workforce dilemma and still grow your business and use those people for what people are designed to do. You go back to lean methodology, and one of the sources of waste is misutilization of human assets, and that happens more often than we realize. Cobots can help reduce that waste.
Good. Another question: what does a typical downtime look like for cobots, collaborative robots, in continuous manufacturing processes?
So I'll use Universal Robots as an example, obviously. So we build our robot for mitigation of downtime. That's inherent in the product design. If you've got a joint failure, say you run a forklift into a robot or something like that, instead of having to tear the robot apart, refurb it, order parts, et cetera, each of the joints are modular. So you can change out a joint in less than 10 minutes. And that's really where we're trying to go with this, is designing for uptime so that, things happen in a manufacturing environment. Damage happens in a manufacturing environment, especially since a lot of times they're not in cages. So we want our customers to be able to get up and running as fast as possible because your ROI really comes from your production. And that's the most critical thing that we try to preserve.
And I saw on one of the machine tending applications, you had a picture of a sleeve protecting the robot, and that, of course, would extend its useful life because you're protecting some of the key components, right?
Yeah, it depends on the application. I mean, the robot is IP54, I believe, in terms of dust intrusion and water intrusion. But I've seen collaborative robots. Actually, there's an example in Dallas here, one of the case studies on our website, of aircraft tooling manufacturer that is using the robot, or has been using the robot for over 3 years in HBOF carbide coating spray, with a flame coming off the end and fine tungsten carbide powder being sprayed on a part, and hadn't had a single problem.
Cobots, like an extremely unpleasant environment.
Oh yeah, for sure, and that's a great example of some of the intangible benefits that you get off of implementing some of this too. They had employees going in full respirator and hoods and suits. It's 100 degrees in North Texas, spraying this stuff by hand, and not only were the people able to remove themselves with their environment, but the robot was reliable and effective in the application.
Another question. Do you have any suggestions regarding safety for workers or bystanders near collaborative robots? One of your slides kind of addressed that, talking about ROI, and if you have to put a cage around the robot because of the end effector versus working side by side with a human.
Right. What a collaborative robot gives you is a set of features that allow you to implement controls to satisfy a risk assessment. The first step of that, as with any piece of industrial equipment going into a manufactured facility, is you need to perform that risk assessment. So as far as specific advice and stuff, we could take that offline with one of our salespeople or one of our partners. But the point that I really want to drive home is it's a more feature-packed robot than a traditional industrial robot when it comes to satisfaction of that real risk assessment, but it does need to be performed.
So when you talk about the robot helps in assessing the risk, what kinds of things would, or what bit of information might it provide to help ease the challenges involved in a risk assessment?
Well, the robot doesn't necessarily help assess the risk. When you do a risk assessment, you're assessing your hazards and then implementing either engineering and process controls to satisfy that. What the robot helps you do is implement those engineering controls, such as force and power limiting, speed limiting of the robot, setting up safety planes, et cetera, to help at a lower cost and investment implement those controls to help satisfy the needs dictated by that risk assessment.
So because of the design of a collaborative robot, you would have to do less integration than you would if you were working on a regular industrial robot around humans?
Potentially, yes.
Yeah. Here's another question. How can collaborative robots be used in gas metal arc welding and gas tungsten arc welding operations? Boy, I think you had an application photo that showed a bit of welding as well.
If we didn't in this presentation, I know we certainly have done it. The interesting thing about the welding market is the labor problem is extremely pervasive. I think the last numbers I looked at were around the end of 2017. By 2021, they were projecting a shortage of over 300,000 welders in the U.S. And these are even stronger numbers than some of the general manufacturing. Think of what robot's been welding for a long time. What the collaborative robots tend to do in welding is make it much, much easier to program and implement that solution, so that it, once again, acts as a force multiplier. So you're taking knowledgeable welders, now not robot engineers, and being able to provide them with an additional tool to expand their capacity in the welding market.
Good, thank you. Let's see. Can collaborative robots be used in vision-guided applications and for end effectors that use force sensors?
Absolutely, we do it every day. One of the things that I do actually is facilitate the plug-and-play nature of a lot of those accessories through relationships with like Cognex and SICK, for example. And, we actually have a built-in force sensor on the E-Series of our robots, but we also have partnerships with companies like ATI, Robotique, that make force sensors that plug and play into the robot. The fact that it's collaborative doesn't restrict you to any type of end-arm tooling or anything you'd be able to do with traditional industrial automation. The UR Plus platform and Universal Robots simply tries to eliminate as many of those barriers to integration of those products and those accessories as possible. That, again, drives down to your ROI, reducing those ancillary costs of the installation, enabling the same applications at a lower cost, faster return on investment.
That's with the vision. I've seen vision work a few different ways with robotics. One, to put an array on the robot itself and then use the robot for inspection. And then another way might be able to have vision either on the robot or near where the robot is operating to help direct what the robot is doing in the application. So I guess there's just a myriad ways that vision could work into it.
Correct. I mean, typically that decision of whether the stationary mount a camera or put it on the robot is dependent on, our lighting conditions, and in a lot of cases, cycle time. Maybe a stationary camera might, since it's always bearing down on the area that you're trying to pick from, or whatever, is always looking at that. The cycle time might be a little bit faster. But once again, the fact that it's a cobot doesn't change anything in these applications. You can absolutely implement any vision solution that you can think of with industrial robots in a collaborative robot, oftentimes more easily.
And then on the other half of that question, the force sensor application, I know I've seen some brilliant buffing applications where the force sensor is used in the end tool so that exactly the right amount of force is applied by the robot and the effector. I imagine you've seen quite a few applications as well with force sensor applications.
Absolutely. The case study we actually discussed earlier at All Access Machining, their first application was using a force sensor with the robot to apply a consistent finish to an aluminum part that had finish requirements for their customer that were pretty stringent. And once again, that was also a repetitive stress risk. They had an employee that was getting on up there in years that was having shoulder problems from sanding this. And of course, the worse the repetitive stress got, the worse the quality of the part got. And they've been able to implement a UR with a force sensor and a sanding attachment to really drive up their quality and please their customer, as well as reducing their risk.
Right, and if you're avoiding a workman's comp claim, that really adds to the ROI.
Absolutely.
I imagine there's a full range of ROI arguments, and you gave a lot of them. Are there best ROI arguments standing out to give business owners when they're trying to justify a collaborative robot purchase?
Well, yes. I mean, typically our sales personnel and our distributors will actually go through and help the customer generate an ROI. I do think one of the things that's quite often overlooked is the reduction of risk in that. Now, it's hard to put a number value on, but it's not hard to put an experience value on if you've had a workman's comp claim or something like that. We have typical parameters that we look at, cost of additional employee, cost of hiring additional employees, turnover costs that can potentially go into that ROI, pretty much all the factors that we mentioned over there. But that's really a lot of times the result of a conversation with the business owner, because we want to understand what your problems are and how to apply the technology to solve those problems. And, typically when there's a problem, there's an ROI impact associated with it.
Early when you have those conversations, sure. When you have those conversations with customers, do they have a clear sense of how they're going to implement a robot, or is it more wide sweeping that, you know, gee, this stuff is cool, I know we can use it, could you help us look?
It kind of runs the gambit, because if you look at our market that we're having a lot of success in the small to medium sized businesses, a lot of times they may become initially aware of this conversation and they don't necessarily know how they would utilize it, but they see a benefit. It's one of the great things about our sales process at Universal Robots with our distributors and with our own folks is really being consultative with that customer, walking through the facility. A lot of times we find the initial idea wasn't always the highest return on investment or the best application of the technology. So we like to guide customers in a way that's going to make them as successful as possible initially to generate that ROI so that they're able to scale. That goes back to the point about you don't have to automate everything. And that is probably one of the bigger misconceptions that we run into, is that customers are like, yeah, well, we could do this, but we have to automate the entire line to enable that. Collaborative robots kind of take that out of the equation so that you can go after the biggest bang for your buck incrementally in an application and really help drive that customer towards the best solution for their business.
Great. Well, here's another, let's see. Are there special system software consideration to support collaborative robots? So I guess, does collaborative robot software differ from other software that help robots operate?
Yeah, it typically does, but it's in the right direction. It typically, well, at least with Universal Robot software, it is different than you would see from a traditional industrial robot, but that's a good thing, right? Because it's much easier to use, the learning curve is lower, and the approachability from the operator is much lower. So you're not as much slave to a software expert that understands that particular control methodology, programming language, etc. They can be up and running in a matter of hours or days, or in some cases minutes, on our software to do something useful. So yes, it's different, and that's quite honestly one of the sources of ROI, a fast ROI.
So you mentioned one customer that had purchased, 3 robots for the first time and had them up and running in a very, very short amount of time. I imagine the programming is part of that consideration.
Correct. In fact, if you do a Universal Robot sales call, a lot of times the sales personnel will pull a robot out of their trunk, set it up on a conference table, plug it into the wall, and the pendant is in the hands of our customers during that initial sales call, and we've already trained them how to do basic programming on the robot. It's extremely easy to use.
Very cool. Oh, and here's another question. Do collaborative robots have multifunction tool heads? I guess that would go to the end-of-arm tooling options.
Yeah, absolutely. There's no restrictions on that. It's 4 bolts and a flange, both on the base of the robot. You can mount it wherever you want, and also on the tool flange. So, if you want to have 2 grippers or a gripper and some other device on the end of the robot, you can absolutely do that and set multiple TCPs. There's also companies out there that, ATI, for instance, makes automatic and manual tool changers for the robot so that it can switch out and change applications very easily.
I think one of the pictures, I don't recall if it were in the slides or if it was in the video, but it looked like you had one mounted right on the side of a tool cabinet, and it was just reached right down in there and grabbed the right bit or tool piece.
Yeah, well, if you look at mounting a traditional, large-scale industrial robot, you're talking about welded steel fixtures that these things are bolted on or welded onto. When it comes to at least a UR cobot, it really is 4 bolts and a flange, and you're talking about a 6 or 8 foot or 6 or 8 inch diameter base that you can mount upside down, you can mount on the side of anything, you can mount it on a mobile stand. So it doesn't take up much more space than a person, which allows you to implement the robotic system into existing processes at minimal impact.
Oh, here's a question. Is there an ROI calculator available? And if not, what might be some of the key measurable inputs for calculating ROI?
I don't think we have one available on our website. We may. I may be wrong on that. Don't take me to the bank. But I guarantee you, if you reach out to one of our sales folks, they can provide you with something to help you walk you through that. The inputs to the ROI are really going to depend on your business. There are some general inputs in terms of, like we mentioned, turnover cost or cost of additional employees if you're adding a shift or something like in that case study, where they're able to, okay, well, we can't hire 15 people to work 3 a.m. to 6 a.m. or whatever, but the robot, compared to the cost of what it would take us to do that, is a much faster payback and much more low impact on the implementation. So my advice would be really go through the consultative process and let's figure that out and walk the floor of your facility and let's figure out the problem we're trying to solve and we figure out the ROI.
With the advancement of IIoT initiatives, that would be an industrial Internet of Things, how would that affect the use of robots, and how can you prevent intruders from accessing or controlling the operation of robots that are IIoT controlled? So I guess that would go to cybersecurity of robots and remote access for troubleshooting and just general cybersecurity.
Yeah, you're generally in the realm of systems integrators or consultants associated with the IIoT project or your ERP system. In that case, in terms of network security and that kind of thing, what we provide on the robot side, when you purchase a UR, it comes with all the I/O interfaces and everything you would need to hook up any other devices like a network switch or whatever that you would need to. I wouldn't be qualified to answer, questions about cybersecurity and all that kind of thing, to be honest.
Well, in general, I would imagine you'd recommend against putting the password on a sticky note on the screen next to the robot.
Well, yeah, there's basic things like that, but that is an important point, is a lot of the functions, and especially the safety functions of the robot, can be password protected and access controlled locally. But, there would have to be an IoT or an IT risk assessment done anytime you're hooking something up to the LAN or to the internet.
Great. Oh, here's another great question. Training for installation and running the robot, how long does all of that take? And certainly with all the concerns about demographics and turnover and hiring people, training is a big issue. Do you offer training? Absolutely.
That's one of the most important differentiators that we have. It's called the Universal Robots Academy online. That actually emulates the Teach Pendant as a 3D representation of the robot that you can go through prescribed modules that I believe are about 15 minutes long a piece on the basic topics that will get you, for lack of a better word, a little bit dangerous on the subject. To be able to do basic operations, pick and place, hook up something to the I/O, control a light curtain or a gripper or whatever. Additional to that, Universal Robots does offer training through our distributors. A lot of times our distributors will offer some training with the purchase of a robot. And then there's an additional layer where we do some in-office training that's available to our customers. So it's really scalable depending on what your resource requirements are in the training. But the software itself and the training requirements compared to traditional industrial robots and traditional automation are inherently much lower. So you're not talking about weeks upon weeks of training to make the robot move. You're talking about, really minutes or hours through the online training, and the in-person, in-office training is usually a matter of of days if that's necessary.
How much does it cost for the online training academy?
The online training is absolutely free. It's available on our website.
Great. Oh, here's another question about safety. What are additional safety considerations when working with collaborative robots as opposed to other robots?
Well, I would say the considerations are the same as any other piece of equipment. What's different is how to satisfy those concerns through the controls and the features inherent in the robot. Good point of reference, and the Collaborative Robot Industrial Safety Standard is TS 15066. And if there's specific questions about that, we can address it offline. But really what the robot's doing is giving you greater ability to solve that.
Great. All right, let me resort the questions here. Okay. Oh, are there regional differences in safety considerations, U.S. versus Europe?
I'm sure there are, but more importantly, there's going to be application-specific requirements depending on the individual business. I'm not personally a safety expert, so I wouldn't be able to comment on the specific requirements, say in Germany versus the U.S. or whatever, but our salespeople in those regions would be able to get some advice or either point the customer in the right direction.
Great. So we do have some other questions coming in. We can certainly get to those offline. Would you like 2 minutes just to offer a summary early of some of the key points of the presentation, some takeaways?
Well, first of all, I want to thank everybody that attended. I love this subject. I find it very interesting, and it's an exciting time to see the emergence of cobots in this industry because that labor issue is real, and we see it every day, not only on our sales calls, but when we're talking to other business owners and other partners in, say, our ecosystem. It's starting to really show itself in the marketplace, and over the next few years, this is going to be a big deal. So please reach out to us if you have any additional questions, or if we can help you out, or look at your application. We'd be happy to see how we can help generate a return on investment for our customers and the attendees of this webinar. So thank you very much.
Well, thank you, Early Ewing, for the great Q&A and the fine presentation, and thank you for the participants for the great questions. In the archive version, there will be additional opportunity to look at Q&A that we didn't get to during the presentation. And before we finish, I'd like to thank special thanks to the sponsor, Universal Robots, for today's event. And now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our future webcasts. Finally, on behalf of Control Engineering and CFE Media and Technology, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.